All right, guys, this video is about the fundamental theorem of calculus, what we usually FTC. Okay. This is kind of tying together integrals and finding area under a curve. So just a few things in this video and just doing some examples. So let's start with an easy one here. Some integral. Let's do cosine. Yeah. Oh no, let's do this one. Yeah, here we go. So you'd be given some function, dx. Now, this is not that important right now, but it will become very important later, and that is that we're integrating with regards to dx, or with regards to x. We'll get to a point where that's really important. We'll have to play around with more letters. But for now, this just means we're integrating with x, and that's fine. So first step is doing what we were doing before, which would be take the antiderivative of x to the fourth. So that would be 1/5 x to the fifth. And we used to say plus c, right? But this is what's called a definite integral because they've given us a specific boundary. They've given us these letters over here, or these numbers, sorry. They've given us those numbers, those boundaries. So if you were to graph it, x to the fourth, kind of like this, it's saying from -3 to 3, we want the area under the curve. That's what this is saying. And so we don't need plus c now because we actually are going to go ahead and plug in values. So what does that look like? So we're going to take our antiderivative, 1/5 x to the fifth. And this is the notation we usually use for fundamental theorem of calculus. Put a 3 here and -3 here. What that means is plug a 3 in. So it's going to give me 1/5, 3 to the fifth. And then you subtract, plugging a -3 in. So it'd be 1/5, -3 to the fifth. And that is going to be, what, 3 to the fifth, and divide that, oops. 3 to the fifth, divide that by 5, 48.6, minus, same thing, but just be careful about your parentheses here, like -3 to the fifth. -3 to the fifth. Oh, and that is -48.6. So careful, we're subtracting a negative now, so that means we're adding them. So 48.6 times 2, 97.2. And that's our answer. That is, again, that's the area under this curve down to the x-axis. Let's do something else here. Let's do one with trig. Let's do, let's say from -2 to 2 sine, yeah, sine of x dx. Okay. Let's see. The antiderivative of sine is negative cosine of x. Okay, but again, don't add plus c. We're just going to do it from, we're going to plug in a -2 and a 2. We're going to subtract them. So we do that first one, that's 2. So, oh, these are, I probably should pick not those numbers, but it's okay. I should have picked something with like rate with pi in it or something. But so let's see, negative cosine of x, not x, cosine of 2 minus negative cosine of -2. Now, the reason that, well, never mind that. So again, I'm sorry I picked such bad numbers here, but the thing is that cosine of 2 and cosine of -2 are actually equal the same amount. Okay, because of the type of function it is. That's just how the way it works out. So what you end up getting is negative cosine of 2 plus cosine of 2. But again, these things are equal to each other. So you're basically saying negative something plus that same something equals 0. Now, if you were to graph this, sine, and this is, yeah, sine graph. Take on it. If you were to graph this, so it kind of looks like that. Let's just say we picked these points. Because I picked the same distance on either side, come on. Sorry, I'm having problems here. Now, it looks like there's a lot of area there, right? But we got an answer of 0. So what does that mean? That means when we have area below the x-axis like that, it negates it. It's negative. It counts as negative. So we can have integrals finding area, but actually get negative answers or 0 for answers. So yeah, if you're finding the area that's below a curve like that, it'll count as negative values. So that's something to keep in mind. It's not weird to get those answers.